Reducing CO2 emissions while producing enough cement to meet demand is a global challenge. HeidelbergCement invests in groundbreaking technologies to capture CO2, preventing it from reaching the atmosphere. Some CO2 emissions are inevitable during the production of clinker, the main ingredient of cement, which is responsible for more than 70% of the total CO2 emitted by a plant. Let's examine the clinker production process, where a majority of the CO2 emerges. It's called calcination. The limestone from the quarry is heated through fast-moving hot gases up to 1,000 degrees. The resulting lime powder enters the kiln and is burnt into clinker. At the end of the process, we have CO2 and harmless nitrogen in the flue gas, which currently are released into the atmosphere. But how to reduce the CO2 emissions and so cut the overall carbon dioxide in the atmosphere? One technology focuses on capturing the CO2 at the end of the conventional combustion process by installing a CO2 capturing unit. The nitrogen and carbon dioxide usually released by the process are redirected to this unit and cooled down. While the nitrogen is released, the CO2 reacts and binds with an amine liquid in the absorber. The resulting rich amine is heated up so that the solution splits up again into CO2 and amine liquid. The CO2 obtained is about 99% pure. It's directed into a compressor to be transported away. A second technology to capture CO2 in cement production is the oxy-fuel combustion technology, a process in which combustion occurs in an oxygen-enriched environment. In this procedure, there's a first step where pure oxygen is added to the process instead of air to improve the combustion. The exhaust gases are recirculated to the burner. The second step is at the end of the process, where the gases are redirected to the CO2 capturing unit. They pass through a first compression stage. Sulfur and nitrogen oxides are removed. Moisture is removed by condensation to avoid corrosion. The physical separation of the remaining gases displaces the nitrogen, and the share of CO2 rises up to 90%. A third technology is the direct separation, in which a special reactor replaces the conventional cyclone heat exchanger. For the direct separation process, the limestone is slowly poured into this high-temperature reactor, which is heated to about 1,000 degrees. It immediately splits into lime powder and carbon dioxide. The separated CO2 is not mixed with the flue gas of the combustion process and is therefore more than 95% pure. This means it can be captured and used right after the cooling process. But what happens to this captured CO2 which does not get emitted into the atmosphere? Well, it could be used in many ways: to produce chemicals, enhance plant growth, be transformed into synthetic fuels, or embedded in new concrete, or used to carbonate recycled concrete. CO2 can also be safely stored offshore or onshore. HeidelbergCement, continuing to reduce our impact on air, land and water.